Assalamualaikum and hi. So today I wanted to show to you our laboratory report for experiment 4, which is frictional force. So before I start my presentation for this slide, my name is Nurul Emilia Syafiqah binti Zon, and here is our teammate, which is Siti Munirah binti Yahya, Amira Nur Aribah binti Zaini Lukman, and Nur Syahira binti Ahmad. So to start with, the objective of this experiment is to determine the coefficient of static friction of different surfaces.
For the apparatus in experiment 4, we need wooden block, 50 gram mass, 10 Newton spring scale, string and tabletop. And we move to the procedure. Firstly, the mass of wooden block record as M has been measured. Next, the apparatus as shown in figure 5.2 has been set up. The third one, the tabletop have been sure, stable and horizontal to the ground. Then, the spring scale and the wooden block was attached with the spring. They were placed horizontally on the tabletop. The rubber side of the block had been sure facing it outward. The fifth, 50 gram of mass was placed on the wooden block, and the spring slowly pulled. Once the block started to move, the spring scale reading was recorded. The value as F recorded and was tabulated in table 5.1. Then, step 4, amplify, repeat for 3 trials. And the last one is another 50 gram of mass was added on the wooden block, and in step 5 to 6 was repeat. The step repeat until total of 500 gram mass was on the wood block.
This is the result that we got from this experiment of mass of wooden block with rubber surface. And this is the result that we got for non-rubber surface towards the floor.
Next is the analysis after we have made the experiment, which is the label and the drawing of free body diagram of the wooden blocks. Second is the graph that we plot of static friction force against normal force for the rubber surface and non-rubber surface. So for non-rubber surface, like you have seen at the slide, and the gradient that we got is 0.13 plus minus 0.1 Newton. Next is the rubber surface. Like you can see here, there is a graph that we have plot, and the gradient that we got is 0.27 minus plus 0.1 Newton.
The last question of analysis is compare and discuss the coefficient of static friction obtained. Based off the graph, the coefficient of static friction for the rubber surface is higher than the non-rubber surface. The coefficient for rubber surface is 0.27 ms minus 2, and the non-rubber surface is 0.13 ms minus 2. It is because when the surface is raw, the friction and the pressure for rubber surface will increase.
Next is the question of experiment 4. First of all, how can anti-lock brakes stop a car in a shorter distance than regular brakes? The answer is by engaging and releasing the brakes. The anti-lock brake system, or ABS, prevents wheel lock-up and out-of-control skids. In braking situations where the wheels or a non-ABS equipped vehicle will lock up, ABS will generally provide shorter controlled stopping distance. Next is, from your experiment, which material has the highest coefficient of static friction? Does this agree with your hypothesis? What do you think determines the coefficient of static friction? So the answer is, solid on rubber has the highest coefficient of static friction. This can apply on our hypothesis, which to determine the coefficient of static friction in different surface. An easy way to measure the coefficient of static friction is to place two objects together and then tilt them until the top one slides. The angle of which one object starts to slip on the other is directly related to the coefficient. The coefficient of friction depends on the material used. As an example, solid on rubber has a highest coefficient of static friction. Last of the question, once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. So the answer is, the body will go motion. It is because whenever one moves or try to move over the other and in a direction so as to oppose relative motion on the surface. The force of friction which comes into play when one body slides or tends to slide on the surface of another body is known as ending friction.
And this is the discussion. In this experiment, there will be some parallax error because of the eyes that were not perpendicular to the spring scale. Parallax error can also be when we pull it because of the uneven table surface, so the measurement was not accurate. To solve this problem, we need to run this experiment by knowing the error in the spring scale and do it on a flat table surface to get the accurate result. Since the static friction force and normal force was consist, we can calculate the coefficient of static friction.
So for the last one is conclusion. In conclusion, student can determine by using a force probe to measure the static friction of a weight being pulled on a block of wood. When a wooden block was attached without any rubber and was pulled by a spring slowly, it creates a law of static friction on table surface. Meanwhile, on the other side, a wooden block which was attached with a rubber, it creates a high friction force compared to wooden block without rubber on. Also, the table used to pull the weights on might not have been completely smooth, causing the surface area to not be constant. So the coefficient of static friction with the rubber on greater than without the rubber on.